Okay, welcome to Isifedu blog. This is the section for resolution of vectors. If you missed the introduction to vectors, you can always click on the link and you go through it and see and meet us up in what we are doing. Please subscribe, click on the notification bell close to you for more notifications of anything concerning or anytime we post something. Like, share. If you have any question, drop your questions on the comment section below. Okay, let's quickly jump into this place. Pay maximum attention here. I think this is where the most difficult part of a vector. Okay, the resolution of vector here deals with when you are given more than one vector or more than two vectors. How do you go about that? First, before we venture into that, there are things you need to know about resolving vectors. Now, vectors are being resolved into two components. We have the vertical components and the horizontal component. What do we use to resolve the vertical component and what do we use to resolve the horizontal component? I'm going to show you with a diagram now. Now, this is the vertical component of this vector. This is the horizontal component of this vector. I'm going to use a specific vector. Let me call it maybe velocity or anything. So this is the vertical component, x. This is x. This is the horizontal component, x. Y, this is the vertical component, y. So I have v of y. Now, if I draw my resultant vector v, here also is v sub y. So this is the direction of the resultant vector, theta. This makes an 90 degrees. So how do we resolve to the horizontal component and how do we resolve to the vertical component? Now watch closely. You can pick anyone first. Let's say we are picking for horizontal component. Our horizontal component in this case is v sub x. Now what do? If you are trying to resolve that, behave as if you are not seeing the vertical component. So our focus is on the horizontal component, and because always the resultant will always be given on the resultant vector. So we have hypotenuse and adjacent. Hypotenuse and adjacent. And in using our Scalar tool, anytime you have your hypotenuse and adjacent, you are using cos. So we have cos theta is equal to, remember, removing this, adjacent, which is v, so x over what? Your hypotenuse, which is v. Therefore, if we cross multiply to get our vertical component v sub x becomes v cos theta. V cos theta. So you use cos to resolve for a horizontal component. Please be very careful. You use cos to resolve for the horizontal component. Now let's talk about the vertical component. For vertical component, that is v sub y. You close this. So what you're now seeing is vertical and the resultant. The side facing the angle is the opposite. Y this is the hypotenuse. So we are using opposite hypotenuse. In Scalar tool, that is sine. So we are making use of sine theta is equal to our opposite is the vertical component over the hypotenuse, which is v. So if I cross multiply, our vertical component v sub y becomes v sine theta. V sine theta. So anytime you are asked to resolve vectors, the vertical force or the vertical vector, you are resolving with v sine theta, while the horizontal vector, you are resolving with what? V cos theta. Always note this. Very important. If you cannot know this by heart, always remember how to derive this. So we are going to make use of this now in solving questions. Okay, we have an example on the board to use it and illustrate our formulas when we are resolving to the vertical component and the horizontal component. Now most times they will not mention vertical or horizontal. As you can see in this question, you are going to use your brain to know what they are asking you to do. So they said here, a boat sails with a velocity of 400 meters per second in the direction north, 60 degrees east. If we put down our solution, let's say that this is where the boat starts to sail and is sailing on a direction north. If you draw your cardinal point, this is north, this is east. So it is sailing north 60 degrees. This is north 60 degrees. North 60 degrees. This is our east. This is our north. On a velocity 400 meters per second. So the question now is, find the effective velocity in the easterly and northerly direction. So what is the easterly? The easterly is this way, which is our horizontal component. The northerly, which is this way, is our vertical component. So they are asking us invariably to calculate the vertical component of this movement and the vertical component of this. So what we are going to do is simply apply our formula for easterly direction, which is V sub x. We have that V sub x is simply resolving for the horizontal component. We are making use of your cos. So we have V cos theta. What is theta here? Be very careful. Theta, this is where your test will always get it wrong. Theta is not this. It's not the angle, the resultant mixed with the vertical, but the angle, the resultant mixed with the horizontal. This is our horizontal. So if this is 60 degrees, the total is 90. So what is left here is 30 degrees. So our theta here is 30 degrees, not 60. So we have V, which is the resultant, 400 cos 30 degrees. So 400 cos 30 degrees will give you 346.4 meters per second. 346.4 meters per second. Now that is the effective velocity in the easterly direction is 346.4 meters per second. Now to solve for the northerly direction, let me make use of this space. Now for northerly direction, which is V sub y, we have that V sub y is equal to V sine theta. So we have V, which is 400 sine 30 degrees. And 400 sine 30 degrees gives you 200 meters per second. So the effective velocity northerly is 200 meters per second. Please always be very careful of these questions. You will see different ways of asking this particular question in your exercises and your past questions. Go to those sections. We are going to see where I solved majority of the questions.